L is given by 24 factorial over 20 factorial. So I can write it as 24 times 23 times 22 times 21 times 20 factorial over 20 factorial, because then these two just cancel. That's my value of L. And this is one less than a square. So the answer is going to be approximately 24 times 23, because, I'm timesing that by something that's close to itself. Although maybe it wouldn't be a good idea to use the two biggest, maybe the two smallest. So let's just work out what that would be. 24 times 21. That won't take too much time. We get 24, get 0 here, 8, 2, 504. Okay, so could it be 504 squared? Well, what if I go with the two middle numbers, 23 times 22? Get 46 and 460, which gives me 506. If I want to times those, it's probably going to be 505 squared, but let's now investigate it. So we actually have 504 times 506. Okay, that can be written as 505 minus 1 times 505 plus 1, which gives us 505 squared minus 1. So yes, it is 1 less than 505 squared. Now, to conclude this question, I'm going to show you an interesting fact. It actually turns out that when you multiply any four consecutive whole numbers together, which these are an example, you will necessarily get one less than the square. It's pretty neat. So what I'm going to do is say I've got x, and I'll go with x plus 1 as my next one. Do you know what? I'm going to go with x minus 1, because often that's good because they end up cancelling quite nicely, and x plus 2. And then I'm trying to show that this is 1 less than a square. So if I add 1 to it, I'm expecting to get a square number. That's what I'm trying to show. Okay, like it doesn't look like it from here, but we've only just started. So I'm going to multiply these together, forget the x, because that nicely gives me x squared minus 1. And I'll multiply the x and the x plus 2 to give me x squared plus 2x. Therefore, I get x to the 4 plus 2x cubed minus x squared minus 2x plus 1. Okay, and we can see some sort of symmetry now, like I got 2's there, although that one's a minus and that's a minus as well. But hey, that should be okay. Right, if this is going to be a square, then we can write it as something times something, and it's got to be the same in each bracket. I feel like it's good to put down both brackets, so it's going to have to be x squared and x squared, and then it's either going to be 1 or minus 1. Let's see, I want to get 2x cubed. So if I had an x here, see that's got to be positive, and then an x here, then I'll get x cubed from here and x cubed from here. So I'm going to make that positive and then that negative. So that will get me my x to the 4. It'll get me my 2x cubed. That's the only way I'd be able to obtain that. I'll get my plus 1. I'm going to get minus 2x. I want to do minus 1 times x and minus 1 times x. The minus x squared, well, I'm going to get minus x squared by doing x squared times minus 1, and the other x squared times minus 1, but then I do x times x. So yeah, that's all going to work out. So that is necessarily going to be x squared plus x minus 1 all squared. And that is a proof that any four consecutive whole numbers multiplied together will give a square number. We can now apply this in the question if we wanted to. So x was the second smallest, x minus 1 the smallest. So x is going to actually be 22 here. So I can see that I'd have 21 times 22 times 23 times 24 plus 1 is going to be this thing here. So 22 squared plus 22 minus 1 squared. 22 times 22 is 484. 484. I'm plussing 22 and then minusing 1, so I might as well just add 21, which gets us to 505. So 505 squared, of course. And then if I got rid of the plus 1, it would end up being 505 squared minus 1, like in the form that we're asked for. But yeah, that's a very long way to do the question, of course, but I think it's, worth watching and realizing, and try and proofs like that yourself. But anyway, the answer is 505. Well done.